Okay, some more problems from section 3.6, and this is number 22. Y equals 1 plus the cosine of 2x squared, so we're going to take the derivative of this. So this is just the straight power rule. The derivative of something squared is 2 times that something to the first power. Again, times the derivative of the something, so we have to apply the chain rule. And I underlined in orange the inside term. So the outside term would be something like x squared, and the derivative of x squared is 2x. Or 2 times something in this case, and the derivative of this. And the derivative of 1 is 0, and the derivative of the cosine of something is negative the sine of something, so I should underline that something here. So I have another inside term, so I got a second application of the chain rule, like that. So now we have these rewrites. In other words, and again, everything to the left of this stays the same. So this comes back down here, and now this is going to come back down here, except we can put the negative and the negative in front with the 2, so that's all the only difference. Otherwise, this is a rewrite. So this comes back down, this comes back down, and what's the derivative of 2x? In other words, the derivative of the cosine of something is negative the sine of that something times the derivative of that something, which is 2x. And this is just the derivative of 2x is just 2. And we already had negative 2 in front, so we can put the 2 times 2 as negative 4, so that's what we have, negative 4. 1 plus the cosine of 2x times the sine of 2x. So that was pretty straightforward, I hope. But again, we are applying the chain rule twice. This was the inside part for the first function, and then this is the inside part for the second function. Actually, that's the derivative of the inside function, or the first inside function. Okay, I hope that is clear. Okay, let's take a look at number 24. So we're going to take, we've got y equals the square root of the tangent of 5x, so we're going to take the derivative of this. Well, remember, my outside term is like the square root of u, and my inside term is like the tangent of u. Then I've also got, or some u, then I've got another u is 5x, so I'm going to do, again, a double application of the chain rule. So first of all, we know the derivative of the square root of x is 1 over 2 times the square root of x, or the square root of something. So the derivative of the square root of something is 1 over 2 times the square root of that something times the derivative of the something. So again, there was my inside function. That was my outside function. So we rewrite this. This is rewritten the same thing, and then I take the derivative of the tangent, and the derivative of the tangent is the secant squared of something times the derivative of that something. I keep doing that until the derivative of the something is 1, then we know we're done. All right? So again, the derivative of the tangent, right over here, the tangent of something is the secant squared of something times the derivative of that something. So again, we have to rewrite that just exactly the same inside. And then the derivative of 5x is 5. So we now have everything written out. And what we could do is we could put the 5 and the secant squared in the top of the fraction. So this is what we have. And for some reason in my answers, they chose to make this a negative and not write fractions. So but they still couldn't get away with the 5 halves. I guess you could have written 2.5 and not had anything in the denominator, 2.5 times this, but they wrote 5 halves. And then put this up top, so in it that the square root of the tangent of 5x is the same thing as the tangent of 5x to the 1/2 power, then they moved it up to make it a negative 1/2. So that's just kind of manipulating that up there. There's your 5 over 2, and there's your secant squared of 5x. That's your final answer. All this, though, this answer is fine. Okay? So that was number 24.